Constructing a transaction. Alice's wallet application contains all the logic for selecting appropriate inputs and outputs to build a transaction to Alice's specification. Alice only needs to specify a destination and an amount, and the rest happens in the wallet application without her seeing the details. Importantly, a wallet application can construct transactions even if it is completely offline. Like writing a check at home and later sending it to the bank in an envelope, the transaction does not need to be constructed and signed while connected to the Bitcoin network. Getting the right inputs. Alice's wallet application will first have to find inputs that can pay the amount she wants to send to Bob. Most wallets keep track of all the available outputs belonging to addresses in the wallet. Therefore, Alice's wallet would contain a copy of the transaction output from Joe's transaction, which was created in exchange for cash in the previous chapter. A Bitcoin wallet application that runs as a full node client actually contains a copy of every unspent output from every transaction in the blockchain. This allows a wallet to construct transaction inputs as well as quickly verify incoming transactions as having correct inputs. However, because a full node client takes up a lot of disk space, most user wallets run lightweight clients that track only the user's own unspent outputs. If the wallet application does not maintain a copy of unspent transaction outputs, it can query the Bitcoin network to retrieve this information using a variety of APIs available by different providers, or by asking a full node using an API call. The below code block shows an API request, constructed as an HTTP GET command to a specific URL. This URL will return all the unspent transaction outputs for an address, giving any application the information it needs to construct transaction inputs for spending. We use the simple command line HTTP client curl to retrieve the response. Curl https://blockchain.info/unspent?active equals 1cd ... The result is a list of unspent outputs. The response in the above code block shows one unspent output under the ownership of Alice's address 1cd ... The response includes the reference to the transaction in which this unspent output is contained and its value in satoshis at 10 million, equivalent to 0.1 Bitcoin. With this information, Alice's wallet application can construct a transaction to transfer that value to new owner addresses. As you can see, Alice's wallet contains enough Bitcoin in a single unspent output to pay for the cup of coffee. Had this not been the case, Alice's wallet application might have to rummage through a pile of smaller unspent outputs, like picking coins from a purse until it could find enough to pay for the coffee. In both cases, there might be a need to get some change back, which we will see in the next section, as the wallet application creates the transaction outputs. Creating the outputs. A transaction output is created in the form of a script that creates an encumbrance on the value and can only be redeemed by the introduction of a solution to the script. In simpler terms, Alice's transaction output will contain a script that says something like, "This output is payable to whoever can present a signature from the key corresponding to Bob's address." Because only Bob has the wallet with the key corresponding to that address, only Bob's wallet can present such a signature to redeem this output. Alice will therefore encumber the output value with a demand for a signature from Bob. This transaction will also include a second output, because Alice's funds are in the form of a 0.1 BTC output, too much money for the 0.015 BTC cup of coffee. Alice will need 0.085 BTC in change. Alice's change payment is created by Alice's wallet as an output in the very same transaction as the payment to Bob. Essentially, Alice's wallet breaks her funds into two payments, one to Bob and one back to herself. She can then use the change output in a subsequent transaction. Finally, for the transaction to be processed by the network in a timely fashion, Alice's wallet application will add a small fee, This is not explicit in the transaction. It is implied by the difference between inputs and outputs. If instead of taking 0.085 in change, Alice creates only 0.0845 as the second output, there will be 0.0005 BTC left over. The inputs 0.1 BTC is not fully spent with the two outputs because they will add up to less than 0.1. The resulting difference is the transaction fee that is collected by the miner as a fee for validating and including the transaction in a block to be recorded on the blockchain. Adding the transaction to the ledger. The transaction created by Alice's wallet application is 258 bytes long and contains everything necessary to confirm ownership of the funds and assign new owners. Now the transaction must be transmitted to the Bitcoin network where it will become part of the blockchain. In the next section, we will see how a transaction becomes part of a new block and how the block is mined. Finally, we will see how the new block, once added to the blockchain, is increasingly trusted by the network as more blocks are added. Transmitting the transaction. Because the transaction contains all the information necessary to process, it does not matter how or where it is transmitted to the Bitcoin network. The Bitcoin network is a peer-to-peer network, with each Bitcoin client participating by connecting to several other Bitcoin clients. The purpose of the Bitcoin network is to propagate transactions and blocks to all participants. How it propagates. Any system, such as a server, desktop application, or wallet, that participates in the Bitcoin network by speaking the Bitcoin protocol is called a Bitcoin node. Alice's wallet application can send a new transaction to any Bitcoin node it is connected to over any type of connection, wired, Wi-Fi, mobile, etc. Her Bitcoin wallet does not have to be connected to Bob's Bitcoin wallet directly, and she does not have to use the internet connection offered by the cafe, though both these options are possible too. Any Bitcoin node that receives a valid transaction it has not seen before will immediately forward it to all other nodes to which it is connected, a propagation technique known as flooding. Thus, the transaction rapidly propagates out across the peer-to-peer network, reaching a large percentage of the nodes within a few seconds. Bob's view. If Bob's Bitcoin wallet application is directly connected to Alice's wallet application, Bob's wallet application might be the first node to receive the transaction. However, even if Alice's wallet sends the transaction through other nodes, it will reach Bob's wallet within a few seconds. Bob's wallet will immediately identify Alice's transaction as an incoming payment because it contains outputs redeemable by Bob's keys. Bob's wallet application can also independently verify that the transaction is well-formed, uses previously unspent outputs, and contains sufficient transaction fees to be included in the next block. At this point, Bob can assume with little risk that the transaction will shortly be included in a block and confirmed. Tip: a common misconception about Bitcoin transactions is that they must be confirmed by waiting 10 minutes for a new block, or up to 60 minutes for a full 6 confirmations. Although confirmations ensure the transaction has been accepted by the whole network, such a delay is unnecessary for small value items such as a cup of coffee. A merchant may accept a valid small value transaction with no confirmations, with no more risk than a credit card payment made without an ID or a signature, as merchants routinely accept today.